Hello. In this video, I want to look at an application for logistic functions. So a company sells 990 units of a new product in the first year and 3,213 units in the fourth year. They expect that sales can be approximated by a logistic function leveling off at around 100,000 in the long run. A, find a formula for S of t for the sales as a function of time, and B, find the rate of change of sales after 4 years. Okay, so because we're looking at a logistic function, I'm going to use either the first or the second form of the logistic function. Just because it feels right, I'm going to go ahead and look at the first one. So here we need to figure out what are M, G0, and K. Those are the three things that we need for a logistic function. So to do that, well, what does M represent? M represents the maximum amount. In this case, it tells us that we're leveling off at around 100,000 in the long run, so M would be 100,000. Good. G0 is the initial amount that is produced or sold. In this case, they are selling 990 units in the first year. That means that G0 is 990. Excellent. And I don't actually know K to begin with, so let's go ahead and write down the function, at least as far as we know. That tells me that G of t is equal to M, 100,000, times 990. Good. All over the G0 of 990 plus the M, 100,000, minus the G0 of 990. Ooh. Good. And then E to the negative, now K, M, and T. M in this case is 100,000, so it's going to make that minus 100,000 KT. Good deal. And that's the function as far as we know. But we need to figure out what K is. To do that, we have to look at what else we're given. We're told that in the fourth year, we're going to sell 3,213 units. Now, what that tells me is that G of 4 is equal to 3,213. So what that tells me is that this entire G of t can be replaced with 3,213. And it also tells me that the t can be replaced with 4. So let's see what happens. That gives me 3,213 is equal to, now 100,000 times 990, if you want to multiply that out, that's just 99 million. And then all over the 990, and then 100,000 minus 990. Oh, what is that? 999,010? Yes. No, 99,000. There we go. 99,010. And then E to the negative, now 100,000 times 4 would be negative 400,000. And then K. Excellent. And at this point, we just solve for K. We need to get rid of this denominator, so I'm going to multiply both sides by that denominator. That's going to give me the following. We have 3,213, and then times the entire denominator of 990 minus 99,010, e to the negative 400,000 k. Excellent. And then all that's going to equal 99 million. Good. Now, here's the thing. Notice that I need to solve for the k here. That means I need to get rid of the 3,213. So I'm going to divide both sides by 3,213. Doing so is going to give me the following. It gives me 990 minus 99,010 e to the negative 400,000 k is equal to that 99 million all over 3213. Good. Now, I'm not going to figure out what that is yet. I'm going to wait till the end. Subtract the 990 from both sides. It's going to give me negative 99,010 e to the negative 400,000 k. And all of that's going to equal that 99 million over 3213. And then we're subtracting off that 990. Awesome. Now notice that we have e to the something times all of this, which means we need to get rid of all of this, which means we're dividing both sides by negative 99,010. So e to the negative 400,000 k is going to equal that 99 million over 3213 minus 990. Then all of that will be over that negative 99,010. Awesome. Now notice that this over here is just one big number. That's all it is. And I don't really like writing that down so often. So what I'm going to do is I'm going to let's just let A equal something. Let's let A equal that 99 million over 3213 minus the 990, and then all over negative 99,010. And the reason I wanted to do that is because of the following. We now have e to the negative 400,000 k is equal to that capital A. And notice that this is just an exponential expression. That's all it is. So since this is an exponential, we want to go ahead and convert it into a logarithm to solve for the exponent. That means that negative 400,000 k is going to equal, now the base here is e, which means I need to use the natural log of A. Excellent. And then just divide by negative 400,000. So k is going to equal the natural log of A, and then all over that negative 400,000. And that's going to give me k. And once you know k, we can just plug it in here, and that will give us what we have in our exponent. Well, we'll multiply by negative 100,000 as well. And now that we have that, we will go ahead and go to the calculator, type everything in so that we can get things into some decimals. It's a little bit weird working with just a bunch of numbers right now. Alrighty, that means we need to go to the calculator, so I will see you there. Hello. Welcome to the calculator. Now, to do this, the first thing we want to do is we want to figure out what A is. So to figure out A, we're going to use alpha y equals enter. And notice that in the numerator we have another fraction to begin with, so I'm going to do another alpha y equals enter. So notice we have a fraction over fraction in the numerator. And that was 99 million, so 99 and then million, which is 6 zeros. And then right arrow down to 3213. Now do right arrow again to stay in the numerator, and then subtract off 990. Awesome. Now go to the denominator and type in the denominator of negative 99,010. Excellent. And that's going to give me negative 0.3012051806, and we need to store this into the calculator. So press STO at the bottom left, and then store this into A, and A would be alpha A. Enter. Now notice that if I just did A, we get negative 0.30 blah, 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 blah. So that is what that is now. And then we can just figure out what K is by typing in that expression. We have alpha y equals enter. Now natural log is on the left-hand side, and notice that that's where you get the exponential as well. So natural log of A, which is alpha A there, close parentheses, and then right arrow to the denominator and type in the negative 400,000. Enter. What did that do? Second enter, second enter. Oh, that needs to be positive. Why is that negative? Ah, I see what I did. It's always positive the entire way. I'll show you in the notes, but it is positive the entire way. So plus, 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 and plus. There we go. So that denominator, actually, that should not have a negative. I'm hoping some of y'all were yelling at me throughout this entire video. So delete that. Excellent, that'll work. Now store that into A. Awesome. And now do our expression. Alpha y equals enter, and the numerator will be natural log of A, close parentheses. And then in the denominator, we have negative 400,000. Enter. Awesome. And notice that this is going to be basically 3 times 10 to the minus 6. Now, we do need to multiply that by the exponent of negative 400,000. So multiply by negative 400,000. Whoop, sorry, not negative 400,000, negative 100,000. My apologies. I'll show you why in a little bit. Okay, so there you go. So negative 0.299999898. In other words, negative 0.3, basically. Okay, good deal. Now that we know that, we can go ahead and go back to the notes, and I'll show you where that minor mistake happened. I'll see you there. Okay, so welcome back to the notes. I went ahead and wrote down what we saw. K was 3, and then we saw that E minus 6. Now, I didn't mention this as strongly as I should have. What this means is it's exponential expression, or it's scientific notation. 3 times 10 to the minus 6. That's what that minus 6 means. The exponent using scientific notation is negative 6. Now, if we look up here at the function itself, g of t is right here. That means that I had to multiply that by negative 100,000, the k times the negative 100,000. So that tells me that the negative 100,000 k was going to give me negative 0.3. And that's what I would replace the entire negative 100,000 k with. Now, the mistake that I made was that this plus should have remained plus the entire time. 100,000 minus 990 is a positive, not a negative. So I screwed up there with making that a negative. So that's a positive, which means that's a positive, which means that's a positive, which means that that stayed a positive, which means that this down here was a positive, which meant that that was a positive. So the entire thing, that's what you saw in the calculator. So there you go. And now that we know that, we can go ahead and plug all of this in. And this is going to give me the formula. That means that g of t is the following. Well, in the numerator in the formula is 99 million. The denominator is what? 990 plus 99,010, and then e to the, now the negative 100,000 k is negative 0.3 times t. Good. And this is what we were trying to do this entire time. We were trying to find a formula for, oh, they wanted S of t. Okay, g of t, S of t. This is S of t. My apologies. I'm not going to redo this video because of that. Anyway, that is S of t. B is wanting to know, find the rate of change of cells after 4 years. In other words, now that we have found S of t, we need to find the derivative of this at 4 years. Okay. B, we want to find S prime of t, which means we need to use the quotient rule. So it's going to be the bottom, the 990 plus 99,010 e to the negative 0.3t times the derivative of the numerator. The numerator is 99 million, which is just a constant, so it's 0. And then minus the numerator of 99 million times the derivative of the denominator. Now, the derivative of 990 is 0, and then we have this left over. So times 99,010 e to the negative 0.3t times the derivative of the exponent, which is negative 0.3. then all over the denominator squared. So 990 plus 99,000, 10 e to the negative 0.3 t squared. Excellent. Now notice that all of this is just going to go to 0 because 0 times anything is 0. Over here, negative 99 million times 99,010 times negative 0.3. I have no idea what that is off the top of my head, but I do know that it's positive. So let's type that in. 99 million times 99,010 times 0.3. And it gives me the following. What I see is 2.940597 E12. So 2.940597 times 10 to the 12th power, and then e to the negative 0.3 t, all over the denominator squared of 990 plus 99,000, 10 e to the negative 0.3 t squared. And again, just like before, I'm going to go ahead and let something happen. I'm going to let a equal, well, I'm going to let b equal that. Let b equal that 2.940597 times 10 to the 12th power. So I'm going to take that answer and I'm going to store that into b, which is alpha apps, which is just where you see b. Now that you have that, this is actually the derivative, which means we can figure out the rate of change after 4 years. So S prime of 4 is going to be that b times e to the negative 0.3 times 4, and then all over the denominator squared. So 990 plus 99,010 e to the negative 0.3 times 4, all squared. Excellent. And I'm just going to type this in. I'm not going to show me this topic, or show me typing this in. So alpha y equals enter, b, which is alpha apps, e, which is second ln, negative 0.3 times 4, aka negative 1.2, in the denominator, parentheses, 990 plus 99,000, 10, second ln, which is e to the negative 0.3 times 4, which is 1.2, right arrow, close parentheses, and then square. And then just click enter. And that should tell you 932.9616845. So S prime of 4 would be 932.9616845. But because these are individual units, we want to round this to the nearest whole number, which means we want to round this up, which means S prime of 4 is 933. Now the units here, well, S is in the number of units and T is in years. So this is units per year. And B was asking us to find the rate of change of sales after 4 years. So what this tells me is that after 4 years, the rate of change of sales will be 933 units per year. Now what that means is that in the 4th year, they are increasing the number of sales by 933 units per year, which is, good, considering that in the 4th year, they were selling 3,213 units. Now, notice that there's kind of a rate of change. It's not exactly a rate of change, but it's kind of a rate of change in here. And it's here at the negative 0.3. So negative means that it's going up, and 0.3 is related to the rate of change here. Alrighty. Well, that was a lot of work. And here's everything that we just did. Alrighty. Well, I believe I'm going to go ahead and end the video here, and I will see you in the next video. Have fun.